Hi, this video is part of a series in which I learn about programming a retro video game on the Commodore 64 in assembly. The code I'm using is from the game Supernatural, written by Georg Rottensteiner. You may also know the game as Guns and Ghosts. This is not a tutorial, just me learning game programming. Enjoy the video. Alright coders, it's time for part 19. And we're going to be adding a mummy, or a new enemy type, and it's going to have a different movement characteristic. So there's some code moved around, some old code is reused, and some new code is introduced. So I'm going to quickly go over that. Let's first have a look at what exactly is changed. Well, as you can see, there is a new mummy, which is edging along here. But what's important is this. It's going to stop and turn around, right? So at a moment when there is something that is not blocking his fall, which is a space here, that's the moment when it turns back, and it'll do the same there. This bat behavior, what's important to notice is that it's not being blocked by any of the floor units here. It's not even being blocked by any of the wall units here. So this sprite, this object, can actually move off screen if we wanted it to. This bat is not being blocked by any of the floor units, but it is being blocked by the actual wall units. That one, the up and down one, is being blocked by floor and wall units. So this movement blocking behavior, that's changed. Another thing that's changed, you can see here at the bottom right, is that the level number and the lives have moved position. Score is still in the same place. So let's go over this. As usual, I'm going to use GitHub to track the changes, so that I'll be looking over to the right to see what the next change actually is. I'm going to pull it up here. Changes. Okay. Now, the first big change is this table that's new. It's called screen back line offset table high. So these are the high parts of the addresses of the first character of each line in the backup of the main screen, which means that as soon as an object is placed on screen, it overwrites some of the characters, and this backup will remain the same. This will always be a copy of the original screen that was built, and we're going to use that. But this is the first time that this exists. We've not seen that before. Next little change is the text display here. It has changed in the sense that it's become a little bit longer. It's become over 40 characters long, and this has been aligned to adjust right under this level thing. This is a little other change that makes this line appear at a slightly different position, but you know that's not too big of a change. Then there is a new table which is up here, indexed by type. Any table that is that starts its name with the word type is actually indexed by the sprite or object type, which we can find in the active object table. And a new line is added. The last enemy type is starts off with 10 health points, so that's the mummy. It's extra strong. Then there's the start color. Let's see. There, the start color for this type is 1, which is white, so that makes sense. And the mummy is sprite mummy R1. We can also have a look actually at the sprite definitions. Let's see if I can quickly find the sprite project here. That's our player, our bat. Again, you can see the design choice here. We started out testing with a player sprite and an enemy sprite, and now we're left with the remainder of that because this is the first animation, and we have to code around this now. No big deal, but as you can see, the two shapes here. Only one is used, by the way. The animation isn't finished yet, so. But we're just going to concentrate on the movement code anyway. Then let's see. We want to record that this is a type enemy, which is either a 1 or a 0 in this table. Now, here we go. This is the behavior code. There's the bat left right, which has changed its code. The bat up down I don't think has changed. The bat 8 is the only one that has the original move left and move right code at the moment. It doesn't check for any blocking. The left and right bat looks for blocking. The way this is organized is that the behavior code. Let's just jump to the behavior code. So any behavior code will call an object move left. This one uses the object move left blocking. So and that will call the move sprite left function. So there's basically 3 levels. There's the behavior code, there's the object move code, and then there's the sprite move code, right? So if we go to this behavior left-right stuff, it does the animation, it does the direction change, and then it says, okay, at the right moment it says object move left blocking. Let's see. If we're going left to that declaration, we check whether we're flush, and if we can move left, we just check whether or not the character to our left and below is blocking, yes or no. And if it isn't blocking, then we have to check whether there's a third check needed. Remember, if we're an object moving left and right, we can be flush with the characters in a vertical sense, but we don't have to be. So if we're not, we have to check 3 characters. If we're flush with the character grid, then we have only 2 characters because the sprite is 2 characters high, right? So, but it does that. Nothing's really changed except this code. We know this already, but this code really checks for blocking characters. There's also an object move left without blocking, so we'll find that this way. By the way, let's see if I can find the entries here. If we just go to the behavior bat 8, which is the bat that's going in circles, it's supposed to be figure 8. This just does object move left. See that? If we go to object move left, it just checks the delta and says move sprite left. It doesn't do anything else except just moving the sprite. It doesn't do any block checking. So it's not. That is funny actually, because I still don't see how the bat. Let's check that out. Let's check out how the bat that's going in figure 8. Oh, see, it doesn't do that at all. The bat that goes in a figure 8. Let's see. Go to declaration. It doesn't do any checking at all, whether or not it can move left. or whether it's blocked by any character. It just goes. So it can move off screen actually. Okay. Let's look at. We've done the left, right, up, down. I get that. Let's look at the behavior of the mummy, because that's actually got something new introduced here. So this is a walking enemy, and a walking enemy needs to be flush with a floor, so that we have to keep that in mind when we design levels, because this code assumes that we're walking on something, that we're flush with the characters and that we have something carrying us. Otherwise, we'll have to do something with that. This code will change direction as soon as, see this, there's this toggle direction. So this one will change direction as soon as we run into something that we can't stand on. Again, the code is the same. We have the delay generic counter, then we have a movement update, so we increase the position, blah blah blah, compare with 4. Okay, this sprite actually has its own. We don't increase any position here. We wait 7 more for, as you can see, the mummy moves very slowly, so there's a generic counter that counts down, and then when that's counted down, we start changing, or increasing this counter until it reaches 7, and then we do the actual move. So let's look at what happens when we walk left. So here we go. We check whether our sprite is flush. There's no sense in checking any blocking unless we're flush with the characters. So suppose we, if we're not flush, then we can just move. So we move sprite left. If we check, if we're flush, then we have to check whether we can move left. So what we do is we get the sprite's Y position, take the low address, put that in 0 page pointer 1. Then we look at the screen back for the for the screen backup for the high address. So this assumes that the high, or that the screen and its backup are aligned in the same way. Otherwise, we could never take the low address out of one table and the high address out of another. The high part out of another. Then we take the X position, and we add 39. So we're moving left. Adding 39 is 1 less than a full line, which is 40, so we end up to, 1 position to our left and lower. We get the character that is there, and then we have to do something funny. We check whether or not the character that is there is checking our fall. So if we find anything there that is not blocking, so that is a space, it says if branch equals 0, then... This is weird semantics, because it says blocked left. Actually, we're finding something that is not blocking us, so it'll cause us to fall. In the meaning of this routine, it says, okay, there's not something that we can stand on, so we're blocked for going that way. And blocked left in this function just means, okay, return a 0, like a false, and return to the behavior code. So that's kind of a weird turnaround. If there is ground to our left, then we still have to check whether there's something standing on that ground blocking us. So again, we take the Y position, we decrease Y now so that we're looking at the higher part, excuse me, where our head is. Again, we look at the backup for the high address. We add the X position, then we get the character that is there. Now we see, hey, is this character blocking? We're not checking for fall blocking here, but just something regular blocking. Remember way at the start of this series, we had two different types of block checking. Now the logic is different. Here it was, we branch when the result equals 0. Now we branch when the result does not equal 0. So is character blocking? If there's nothing blocking, branch not equal 0, then we are blocked left. So if it returns with a 1 that says, hey, we're blocked by something, then it says, okay, it's not equal 0, so we're blocked on the left. This makes sense. But that all the differences in the command here: branch on equal to 0 or branch when not equal to 0. And then we have to check again for something above us to the left. So we're taking quite a wide range for checking whether or not we're blocked. And we set the delta to X. That's like we were flush, so we have to set this value to 8. And then we jump to the can move left code, and we actually move the sprite to the left. So if this is a bit confusing, then I get that, because I was confused as well. But the problem was, and let's just go back to the game. The problem was that before we just had our bat flying left and right, and we wanted to use that code, but this bat is flying. It doesn't care about what is beneath it. This guy is walking, so we actually have to do something with the stuff that is beneath us, So that's how we had to sort of reuse this code, but change it so that we have walking code, and we have flying code, and we have crazy code, code that's just it doesn't check for any blocking. So that concludes this episode. This was 19, so the next one is 20, and then we'll be at 20%, won't we? Okay, well, thanks for watching, and I'll see you next time. Bye-bye.